Well, hello guys and welcome back to Mr. G Physics. We are going to be solving today a question for the grade 11. This one was a question 2 from June 2023 done in the Northern Cape province. Now this question say molecules such as carbon dioxide, water and ammonia are formed through covalent bonding. Question 2.1, define the term molecule. Now, what is a molecule? A molecule is a group of two or more atoms that are covalently bonded and function as a unit. In other words, the result of a covalent bonding is going to be a molecule. So you have to remember that one. All you have to do is to please make sure you write that definition. The next question, one of the above molecules does not have a lone pair of electrons on the central atom. Draw the Lewis dot diagram for these molecules. But you know what? We are going to draw the Lewis dot diagram for each of the molecules because you need it anyway. Okay, so here are the three molecules. Let's draw the Lewis dot diagram for each of them. Let's start with carbon dioxide here. Now, you need to know that carbon dioxide have one atom of carbon. And it has two atoms of oxygen. Alright, so this is important to know. You need to know how many atoms are there. Second, you need to be able to draw the Lewis dot diagram for each of all these atoms we have here. Let's start with the carbon. So the carbon, we have one carbon with 4 valence electrons. Remember, the electrons involved are the valence electrons. So it's 1, 2, 3, and 4 valence electrons. Now oxygen, we have 2 oxygen, and oxygen will have 6 valence electrons. 1, 2, 3, and 4. You do 5 and 6, and then you have 2 oxygen. Look here, another oxygen, we have 1, 2, 3, and 4, 5, and 6. Those are the valence electrons for oxygen. Now, what we need to know about oxygen right now? Oxygen have 2 lone pair. Those are called lone pair. Those are called lone pair. And note, you cannot separate those lone pair. So they're going to stay together. The only ones you can move are the electrons that are not having lone pair. So note the following, and this is quite simple, guys. Oxygen have 2 single electrons, as you can see there and there. All right, and carbon has 4. So let's say 2 are for one oxygen and the other 2 will be for the other oxygen. They are going to share those electrons that they have and pair. How is it going to work? Well, we're going to place a carbon in the center. Let me use the color used for carbon. Carbon in the center with the single electron. They're going to move in this way because they're going to share with the oxygen. All right, so they must form those pairs. Then on one side, we're going to have the oxygen. Those 2 electrons that were unpaired are going to move together to share with the carbon. There we are. And the rest is the lone pair that we mentioned before. They cannot be moved or separated. The same happen on the other side. We have the oxygen here, and then there is the lone pair. This one is the Lewis dot diagram for carbon dioxide. Alternatively, you can use a line here instead of a bond, instead of the dots. So you can use a line here, there, and there. Those are the covalent bonding. That is alternatively, you can do that. For water, now if you look at water, we have in 2 atoms of hydrogen, 2 atoms of hydrogen. You can see it there. There is 2 atoms of hydrogen and 1 atom of oxygen. One atom of oxygen. So to do this one now, this water molecule, we have to do the same. We are going to do the Lewis dot diagram for each of the atoms, for 2 hydrogen as well as for 1 oxygen. So let's begin with the oxygen. It doesn't matter which one you're starting with. We have 1, 2, 3, and 4, 5, and 6. That is the oxygen. We have two hydrogen. So one hydrogen with one valence electron is hydrogen with one dot, the other hydrogen also with one dot. Now you look here, oxygen have two unpair or single electrons there. You can see them, one is here, the other one is there. So each of them will take a hydrogen. You cannot move those lone pair guys, you keep them where they are allocated. Saying that, we have oxygen, the lone pair will stay in the place they were before. One hydrogen here will share with one hydrogen, one dot, one electron will share with one hydrogen, and the other one will share with the other hydrogen. This is the Lewis dot diagram for water. Alright, you can see that water have two lone pair, one lone pair there and another lone pair there. Then let's go ammonia, which is the last one. And then for ammonia, we have in here, in this case, we have one atom of nitrogen, and it have three atoms of hydrogen. All right, we have that one there. So we're going to do the Lewis dot diagram for each of the atoms. So let's begin with the nitrogen. Nitrogen has 5 valence electrons. You go to the periodic table, have 1, 2, 3, and 4, and 5. So it does have one lone pair there. And you have 3 hydrogens. Each hydrogen have only one valence electron. There we go. Now what you can see here, you can see nitrogen have 3 single bonds. Each of them will take one hydrogen to share that single electron they have there. Therefore, we have nitrogen. Remember, the lone pair, you keep it as it is. There is the other 3 electrons of nitrogen. Each one will take one hydrogen. There we go. This one is ammonia. Now we have here also one lone pair. We can go back to the question. The question now say one of the above molecules does not have a lone pair. Which one is the situation here? The carbon dioxide does not have lone pair. And let's go back there in the central atom. In the central atom. So the answer is carbon dioxide. That is question 2.2. The answer is here. There is carbon dioxide. That is the solution there, or the answer for that specific question. And then you have to draw the Lewis dot diagram, which we answer here at the bottom there. I hope it's clear. This question is quite important, this bonding. Okay? Now, question 2.3. Using Lewis dot diagram, show how water form a dative covalent bond with a hydrogen ion to form hydronium ion. Now, for this one, you need water as it is here. You have water there. Let me move it here. There we go. You have water there. Now, water is going to react with one hydrogen ion. They are telling you here to bond with one hydrogen ion. Now, what is a hydrogen ion? That is H+. So it is a hydrogen that do not have electron, does not have any electron. All right, so now let's solve that question real fast. And here at the bottom will be enough space. I'm going to erase this word of water. This one is question 2.3. So what we have here, we have water, which we are going to do the Lewis dot diagram. I have it done here. I'm just going to rewrite it. We have hydrogen, double bond, a bond with oxygen. This is the lone pair, and there is another hydrogen. Now with this one, you are going to add the hydrogen ion. Know the following. This hydrogen does not have any electron to share with the water. So what is going to happen? Water is going to share one of the 2 lone pair with that specific hydrogen. They're going to share that lone pair, one of the 2 lone pair. So you will have the water still the same as it was. There's the water, but this hydrogen ion is going to move to one of the lone pair. So let's say, for instance, the hydrogen ion is going to be is going to share this specific lone pair. That is what we call the dative covalent bonding. But now this water gain a proton. Look here, it is a positive charge. Therefore, everything, because it gained one proton, is going to be positively charged. This one is hydronium, or in other words, is H3O plus. That is how H3O plus is formed. It is important. It's one of the two that could be asked in the exam. In fact, it's very good for it to be asked in the exam. Write down, okay, we are done with question 2.3. Question 2.4, state two conditions required for the formation of a dative covalent bond. Well, the first condition is that one atom, this is question 2.4, let me write it here, question 2.4. The first one atom must have an empty valence shell, all right, like hydrogen ion, could be atom or ion. The second condition here is that the other atom must have one lone pair. Those are the two conditions for dative covalent bond to form. It's quite simple and is very, very important. It's going to be in the exam, guys. All right, question 2.5, define the term bonding pair. Well, so what is a bonding pair? It's a pair of electrons that is shared between two atoms in a covalent bond. Guys, if we go back to the Lewis dot diagram, when we go to the bonds now, to the Lewis dot diagram, this one here, I'm going to write it in red. This one is a bonding pair. That is what we call bonding pair. All right, so that is the question. In all the cases, bonding pair for water, but also for ammonia, this one here will be bonding pair. Okay, so that is the question there. Write down the number of bonding pair in ammonia. Guys, that is why we draw all of them. We have bonding pair here, we have the following. In other words, they're asking the bonding. So it's 1, 2, and 3 bonding pair. So it is, write down the number of bonding pair, it is going to be 3 bonding pair in question 2.6. The polarity of a molecule is determined by the difference in electronegativity and the shape of the molecule. Calculate the difference in electronegativity between carbon and oxygen in CO2. Now, for this one, we have to go to the periodic table and identify where is the electronegativity. Guys, this number that is on the left side is the electronegativity. In this case, we're working with 2,5 for carbon, 3,5 for oxygen. So all you have to do is to calculate the difference, the subtraction. All right, you come into the periodic table and you look for it. Is really, really simple. So in the first one, carbon and oxygen, there will be the change in electronegativity is going to be equal. I'm going to write En for electronegativity. En like this is equal to 3,5 minus 2,5. Always the bigger number minus the smaller. This is equal to 1. Between oxygen and hydrogen in H2O, you go to the periodic table and you look for the electronegativity of each atom. This one is 3,5, which is oxygen, minus 2,1. That will give you 1,4. All right, and then the change in electronegativity for the last one, nitrogen and hydrogen, that will be 3, which is, this one is electronegativity, which is 3 for nitrogen, minus 2,1 for hydrogen. This one will give you 0,9. That is the electronegativity of each of them. It's extremely easy, that calculation, obvious. You will get 1 mark for each of those calculations. Now explain why CO2 is non-polar and H2O is a polar by referring to the polarity of the bond and the shape of the respective molecules. Now we have to come back here quickly and look for this part here. This is important. We can see that carbon dioxide is a linear molecule. Linear molecule. You need to know the shapes of the molecule. And water is an angular shape. This one is angular. Angular molecule is important. That shape is very important because it will give you now the polarity of the shape. Now, the fact that this molecule is angular, it means it will have 2 poles. I'm talking about water right now here. I'm talking about water right now there. The fact that I have a angular shape, it will give you two poles, and therefore it's a polar molecule. However, we go into a linear molecule because it's linear molecule, not just because of that, but because of the polarity of both of them. This will be a non-polar molecule. I'm going to make another video clear where I explain the shapes and the polarity of the molecules. This could be confusing, and it's important to identify the type of intermolecular forces which could be confusing and coming later on. Guys, thank you for watching. I hope it helped. If it helped, thumb up, subscribe for the channel. I'll see you next time. Mr. Jeep here.